Hi, welcome to clickmeproject.com. Now I am going to explain the project Privacy Preserving Data Sharing using Anonymous ID Assignment. In this project, we are creating network name, ID and password for each network at the time of its registration. By using this ID and password, data is shared among each network efficiently. To achieve secure data sharing, cryptographic technique of RSA symmetry algorithm is used for encrypting and decrypting the data. Let's say start with abstract. An algorithm for anonymous sharing of private data among parties is developed. This technique is used iteratively to assign these nodes ID numbers ranging from 1 to n. This assignment is anonymous in that the identities received are unknown to the other members of the group. Resistance to collusion among each other member is verified in an information theoretic sense when private communication channels are used. This assignment of serial numbers allows more complex data to be shared and has applications to other problems in privacy preserving data mining, collusion avoidance in communications, and distributed database access. The required computations are distributed without using a trusted central authority. Existing and new algorithms for assigning anonymous IDs are examined with respect to trade-offs between communication and computational requirements. This data flow diagram explains the overall process of the project. Initially, the network registration will take place. In this network registration, ID, password and network name is generated. Here the password is used for encryption and decryption process. After the network logged in, it will be compute the data to share among each network. By using the generated password, it will be initially encrypt the data and generate a hash key for that original data. After, it will be transmitted to desired network. At the receiving side, the received network, the data will be decrypted by using the same password which will be used for the encryption. Then after the decryption, the original data will be fetched. From the original data, it will generate a hash key value. After that, it will be checked for the original information, whether it is received original or whether hijackers changed the content of the data. So that to identify the originality of the data, the hash value of both the sended hash value and the generated hash value will be compared. If both the hash values are equal, there will be there was no changes in the content. Otherwise, it will be considered as the data is changed during the transaction by the hijackers. Let's start with demo of this project. First module is the network registration module. It contains two processes. One is registration process and login process. The already registered network is directly go to the login module. Otherwise, it has to register first. Here, host name. I am going to get a host name and IP address for this system, and I am giving network name called network 7. And click get ID. It will ask this network name 7 is asked for the network ID and key value to the administrator. The administrator will generate ID and key to the requested network. Here the check button will check whether the requested register is requested network is already registered or not. If it is already registered, it will show a message like you are already registered. Otherwise, it will generate ID and key value to the requested network and reply to the requested person. Here click generate ID and key value. Here the network ID and key is successfully generated to that network 7. So D is the network ID and this key value is the password which will be used for the encryption and decryption process in future. So then click reply. It will reply to the requested network. So these are all the summarized value of the previous process. Then click next. Here we have to give the host name, IP address and network name, that is network 7, and give ID which is D. Then click here. This is the Next module, it contains view shared and data encryption processes. Click data creation and view data items. This is about the patient detail of a particular hospital. So from these data only we are going to compute secure sum, and we are going to share this data. So click next. Here I am computing number of patients, chest pains and breast cancer, like various types of diseases. So I am computing the count. So after we computed the details, save this. So therefore the data is saved into the database successfully. To view the data, we have to click view button. So this is the overall process of this computer data. Then click next. Click this patient disease information is for computing a specific query which contains some query which contains the data from which will fetch the data from the database. So from the query container I am choosing a data like a 10. That 10 contains a query called select star from, like that. So from this query I am going to compute the data. Click show data. So it shows some data which we can view in the data grid view. So we have to save this computer data for encryption process. Click save data, give name called data 10, click save. Therefore the data is successfully stored in this path. Then click next. So this is the data encryption process. Here we are going to fetch the data which we previously saved. Click fetch original data, click data 10. This is our data we computed previously. Then click here we have to give the password which is generated at the time of registration. So enter the password, then click encrypt. The data is successfully encrypted. Here in the compute hash value, this will compute the hash value using the message digest function for our original data. Click compute hash data. This is our hash data. Then this hash data is used for the content verification process in future. So then we have to save this hash data. Then we have to save the encrypted data. So we are going to save these data into our database. For that we have to give a network ID called, it will save the data like original data, hash data, and click save data base. Then data is successfully stored, and click OK. Then next, this we have to first create a network create node, then assign a ID to those nodes. So click create node, it will generate the nodes. Then click assign ID, it will assign the I have to give a network ID. My network ID is D. Then click get data, it will fetch the data which we previously stored. Then choose the source, that is so network 7 is the source. Then network source destination is which we can select anything, like I am choosing network to network 1. Okay, then click share data. The data has successfully shared. Which next we have to go to the view shared module. So this is our decryption process module. Here we have to give the network name called a network 1. Click get share data, it will click get encrypted data, it will fetch the encrypted value in the text box. So this is our encrypted text value. Then hash data, to get the hash data we have to click the data grid view cell hash data value, then click select hash. It will show the path of the hash data value in this text box. Then enter password which is used previously for the encryption. So I am giving a password, and click decrypt. So therefore the received data is successfully decrypted, which is shown here, and click OK. Next, here this is the content verification process. Here I am going to open the decrypted data. It will read the data which is stored in that specific path, then compute the hash value for this received and decrypted data. So click compute hash. This is our hash value for this data. Then open hash value which is sent from the sender. Here we are going to compare this received hash value and the newly computed hash value. If both are the same, we can consider we can say that there is no hackers and there is no change of content in the during the transaction. If it is not same, we can reject that received file, and we can say that there is a changes in the content. So I am going to open the hash value, received hash value, then click compare. It shows contents are verified, both sent and received contents are same, therefore there are no changes in the received file. The process is successfully done. Thanks for listening.